Looks like I better do that. So the point of story that we can utilize another relationship between angles and sides if you have any triangle, and this is gonna include two sides and angle given right in between. So there's two sides and angle in between is what I have here, and that's what we're going to utilize. So we're going to go with the formulas that this section provides us. So there are three of them. And we already noticed that it doesn't really matter how we call our angles and sides if it's not a right triangle. But what really does matter here is that we have the two sides and angle in between. For example, we just saw the case with my situation on that first picture, but you can also, if I look at the, again, favorite triangle, ABC, and then angles C, B, and A, then we'll be able to notice the interesting relationships. Like, for example, the second one deals with the sides B that we need to find, and we can find it if I have the other two, such as A, C, and angle in between. So we always have two sides and angle in between of them, and that way we use this little law of cosines. Analogously for the third possibility, here I have the two sides B and C. So here's one, B, and here's the other, C. And we also have angle in between, which is A. So whenever you have two sides and angle in between, then you just go ahead and utilize the law of cosines, and you can find either the third side or just about anything that you have in these relationships. So what I want to do is go for the actual exercise. So I'm gonna take a look at problems that pretty much same as in the previous section. So pretty much same as in the section 2 of chapter 8. And now we are going to deal with, again, some more triangles. And that's why, yeah, I forgot to record last time, but I don't think you really missed much because we worked already with these triangles, and now we're going to continue working more. So let me try one of these exercises. So I'm going to share the screen with a board so we have a little bit more room in here, and go with the exercise number 9 that I can draw as a little triangle here. So this will be sides 2 and 4 with angle 45 degrees in between. So this way I have myself a good start. And of course, I also have a little bit extra here, the names of those angles that they want to find. They call one of them as a capital A. Notice they didn't really give me all of the names. They just gave capital A here and a capital C in there. So also there is a side B. So it looks like what we are given in this particular exercise will be a remaining third angle, right? Remaining angle B, as well as side across angle C, which is a little c, and the side across angle A is a little a. So this way, I got myself a good start. So I can continue by working with this either law of sines or law of cosines. So turns out the law of cosines will say here that b squared is equal to other two angles, a squared plus other two sides, c squared. So always, if you're looking for one side, you're utilizing squares of the other two. And then you subtract the 2 multiplied by AC, and then a cosine of that angle in between, cosine of B. So if I want to find B, if I want to lose that square, so I can extract the square root. So I will be square rooting this and get the side B. When you say, Alex, why do they need B squared? It looks like you also always need the side B. And the answer is yes, this is correct. But I guess if they put a square root, they think it's more complicated look for the formula. And that's the point why. So anyways, it's always positive when you extract square root because it's a length of the side, cannot be negative, right? So I go with the 2 squared. So now I'm going to plug in whatever they gave me. A is 2, C is 4, so plus 4 squared. And then I subtract from this 2 times 4 and multiply it by cosine of angle in between, which is cosine of 45 degrees. So this is what I have here to calculate. So let me try to calculate. I need to definitely utilize my favorite scientific calculator and plug everything in it. So let me do that. So it's 4 squared. I want to copy this for myself because otherwise I may forget something. So here it is. Okay, so I'm gonna share back this page with a calculator. So I'm gonna go for the scientific calculator as usual, right? Scientific calculator. And choose first choice Desmos. So we're gonna be utilizing this calculator for extracting the square root. So put the square root here. From now inside the square root, I got 2 squared. So just enter this little by little. I recommend you to also enter this carefully, like here. I want to make sure it's inside the square root, right? So square root, 2 squared plus 4 squared minus 2 times 2 times 4. So I'm gonna just enter everything the way it is because it looks like we have kind of unpleasant looking expression. And of course, I want to have everything in terms of degrees. So we've got the answer. So it's 2.947 something. And remember, the advice is always rounded to the extra decimal digit in terms of if you're given those length of sides as whole numbers, then you go just with one extra decimal place. So I'm gonna now share back my screen and put the answer, which is about 2.9, right? Okay, so 2.9 approximately is side B. So now what? Well, now I can utilize this law of cosines or go back and utilize law of sines if I want to, because now I have ability to use sine b over b is equal to, for example, sine a over a. Since we have all three sides, then I will be able to find the angle A here. Or you could find this angle utilizing law of cosines. So let me find it using law of sines. So we go over what we saw last time in class. And then I'll find the third angle C using this new formula. So it looks like if I need to get sine of A pulled out, because I'm looking for the angle A, then this is going to be A times sine of B divided by that little b, right? So that's how I get sine of A. And then also I'm going to have to use the arcsine. So I'm going to plug in what I have so far. It's side A2, and then sine of angle B is a sine of 45, right? And then we divide this by length B, which is what we just found, 2.9. Okay, so that's another little calculation that I want to put in my calculator. So this is going to be, again, I want to copy this for myself so I don't forget. And let us do this. You probably already did it, right? So let me share the screen again. So arcsine, I need to go to functions, right? Remember, we go main or functions, those two that we care about. So in the functions, I have arcsine, and then I go back to the main menu and see what we have in the parentheses. It looks like 2 times sine of 45 degrees. And then I have to divide this, so division, by 2.9. Okay, so we have this calculated angle, and this is 29 and little something, right? So I can say it's about what, 29.2 degrees approximately. Again, please notice this is all in terms of degrees. So let me write this down here again. So share again this whiteboard, and this is 29.2. Okay, so 29.2 degrees is another angle, and one can say, Alex, you probably don't need to actually calculate this third angle of yours, simply because we know that sum of all angles in triangle is 180, so you can simply subtract this 45 degrees from 180 and 29.2 from it, right? So you can just subtract these angles like that and get the result. Well, it turns out that, as I promised, I can also utilize the law of cosines. Let's say you didn't notice or want to do it the other way. Turns out no matter which way you take, the exercise will be done exactly the same, with exactly the same answer. So cosine B was participating in the previous calculation, so now I need to get a cosine of C. So please notice that in order to utilize this formula, so with a cosine of C, so I'm going to write this as going to be C squared, which is the same as A squared plus B squared minus 2 times A times B times cosine of C. So Notice the analogy. So if side is B, then cosine of B is using. If side is C, then cosine of C is using, as well as the other two sides. So if side is C, then it's A and B as well. So what I'm going to do now is I'm going to try to pull out the cosine. How can I do this? Well, with little algebra, you can bring this two ABs with a cosine of C on the other side and have A squared and B squared minus C squared. So C squared goes over. And then we're going to divide by 2 times A times B both sides of this equation. So this way 2AB will cancel and I have my cosine of C here. So let me write this as a formula that actually appears in a section, but it's nothing else but the way to manipulate a little bit algebraically with this law of cosines. So it's A squared plus B squared, subtract C squared, and you divide this by 2AB. So in order to pull out your angle C, what I need is to take arc cosine, right? Remember that arc cosine, and apply it to this parentheses with A squared plus B squared minus C squared divided by 2 times A times B. So this is what I will actually isolate. And now I'm going to deal with this. So I'm going to get the numbers that we already have for the sides. So instead of A, I use 2. Instead of B, I use 2.9 squared. And instead of C, I use 4. But notice that C needs to be with a minus sign, right? And then 2AB, so it's 2 times 2 times 2.9. And this is what I'm going to put in my calculator and hope that we're going to get the angle that totals with the other two as 180, right? So let us do this. Take arc cosine. So let me share screen here and go for the function now. For a change, it's arc cosine. So I'm going to arc cosine and apply this to fraction. So I want to make sure I put fractional numerator in the parentheses. So this way we're going to make sure that you divide this entirely. So usually when you work with fractions, you should put parentheses. So plus 2.9 squared minus 4 squared. And divided by the product of 2 times another 2. Now here, I guess I don't need parentheses because it will just go pretty straightforward. I already try actually with this calculator. So when I divide this, then arc cosine is giving us the angle that is 108 degrees and 0.1, right? When you say no, Alex, it's just 108 because if you try to round, the following digit is 2, so it's exactly 108. Okay, so let me go back to share my board, and I get 108, and this will be my angle C. Where can I write it? Maybe I'll write it here, 108. So if I decide to double check and see what happens with the other way to calculate this, when I subtract 180, 45, and 29.2, Well, it should get close to it. The reason it's not exactly the same is always because of rounding. You see, we had 2.9, but it was actually 2.9 and some other digits, right? So that's why. And the angle that we produce is not really 108, but it's something different. So point is that there is approximation involved whenever you have some decimals. So when you're using the calculator, but looks like we're subtracting what, 30 and 45 is like 75 and something. So looks like it's 100 and like 506, and we got 108. So it is a little bit different again because we did the rounding. So if you were to keep all the digits that you possibly have, of course, the answer will be pretty much the same. But again, it still rounds because these are irrational numbers. So those are not exact results. So I guess I'll do one more exercise so we can just try to get used to these little manipulations, right? So that'd be, I think, a good practice for all of us. So let me return back to this section, and we're gonna be, well, I guess just picking another exercise. So let's see. Okay, here it is. So in this section, just like in the previous section, I would say problems are very, very similar. And all we're gonna care about is using either law of sines or law of cosines. It is really up to you. So let's try one. Let's try one. Let's say exercise number 21. That's where we don't have a picture of our triangle. So turns out that this is all one big story of utilizing the law of sines or cosines in order to simply go for the all sides and all angles of triangle that is called solve triangle. In exercise number 21, they give us the following: the side A, which is 3, the side C, which is 2, and angle B, which is equal to 110 degrees. So I'm going to try to get this pictured first. And the way we picture is we put two sides, say A, and a little shorter side C, like that. And then the angle will be right in between, because that's angle B. It is 110 degrees. I can even put these numbers here just for fun. So what happens next? Well, I have to make a decision what else I want to find. So this be side little b, and then there be angles A because it's across the side A, right? And same with angle C, which is across the side C. So it looks like we're going to have to utilize the law of cosines. So I'm gonna go for the, let's say, side B, because when you have three sides, you can either use sines or cosines, it's up to you. So we already saw that B squared was a squared plus C squared and minus 2 times the product of these two sides times cosine in between, cosine of B. But without a square, I have to extract my square root. So I think this is probably the most straightforward way to get to the third side. So let's do that. So you have 2 squared and 3 squared, right? And also subtract twice their product, and also multiply it by cosine of angle 110 degrees. Okay, so looks like we are going to put this all in the calculator. So please try to also calculate this, because I think it's a good idea that you are also working on this. So I'm gonna get this square rooted. So I'm gonna be going for the sharing my calculator. So let's see. This is a square root. And now inside the square root, I'll put this little by little, such as a squared plus 2 squared plus 3 squared, right? So did you already produce your answer? 2 times 3 times cosine of this 110, and it's in the parentheses, and looks like it's all inside the square root, so I've got the answer. It's about 4.1. Okay, so it looks like we follow same exact footsteps here. So if I go for the let's get back. See, that's a little bit annoying part of this whole story. So I'm gonna go back to the screen here. So I shared wrong thing. I'm gonna share my board, right? The good thing is board remembers everything we had on it. So this is 4.1. 4.1. And then it looks like I need to find angles, right? So either A or C, whatever one you prefer. So let's say I want to find A. So how to go about that? Well, once again, if you're already familiar with this formula, then you can write this with respect to the angle A. So you can put it down as A squared is equal to the other two sides with pluses, B and C squared, and then subtract twice their product, B times C, and multiply it by cosine of A. So from here, what I can do is pull out my cosine, just like we already did in the previous example, or you could just look at the formula. I guess after the exercise, I will show you it. So it'll be a fraction with the B squared and C squared on the top, subtracted the third side, A squared, that corresponds to our angle A, and divided by 2 times B times C. And therefore, when I want to find angle A, what I do is take arc cosine, right? Arc cosine. So this will be still the same B squared, C squared, and minus A squared. And also divide this by 2 BCs. So looks like this way I can actually find the number that corresponds to this. So I'm gonna go with the B squared, which is 4.1 squared, plus C squared, which is 2 squared. And I need to subtract from this A squared, which is 3 squared, and divide this by 2 times 4.1 times number 2. So this way, I'm going to be able to actually get the calculation, right? So please try to calculate this. Did you calculate it yet? So I'm gonna copy this here for 1 and for 2. So I'm taking the arc cosine. Okay. So share this calculator again. And see, the calculations seem to be tedious, right? But if you redo exact same exercises that I done today, again, on your own, well, then you're going to actually get one exercise and then see that the other will be the same thing. The other exercise will be pretty much the same exact thing. And that's a good part about it. So put parentheses and then divide this by 2 multiplied by 4.1 and times 2. And value of cosine is, value of angle is actually found. Looks like it'd be approximately 44, right? Because if I were actually 43.9, I wasn't careful because the following digit is 3, and that'd be our second angle. So once you found your second angle, then we know that you could use this same formula, but it's too tedious to find a third angle, or you could just go for the fact that all 3 angles produce 180 when you add them. So if this is going to be my 43.9, then I can find angle A by subtracting these 2 angles from 180 degrees, right? And this is much faster, and I highly recommend you to do this instead of messing with this law of cosines, or you could use also law of sines if you like. For practice, maybe it's good, but I guess it's probably no point of doing it because it's easier to make a mistake if you are going to utilize these formulas again and again. Well, you might make a little mistake and the whole calculation will be, I guess, invalid in terms of the answer. Well, on the tests, you probably already noticed that I don't really pick much on the answer. I just want to see your solution. So when I see that you were on the right track, well, most likely you will get a full credit for the exercise because I understand that with this kind of procedures, anyone could mess up, right? Anyone could get a wrong result, and that's, I guess, the main point in here. So I guess this will be another problem that I'd like to just conclude this story with, because we just keep solving triangles, find other sides and remaining angles, and it's procedure of the type that we just keep doing and doing, and all the time it's there with us. So there'll be one more section in this triangle, triangle, in this chapter about triangles, of course, that we're going to look at next time, because today I know that we're facing the long weekend coming on us, and that's why I'm not going to continue, because that's the best I can do for you in terms of giving you a little break. So